Let's talk about logarithmic functions. As we know, the log functions are the inverse of exponential functions. If the exponential function can be written in this form, base to the power of exponent is equal to the answer, or b to the power of x is equal to a, the corresponding inverse function, which is called as the log function or logarithmic function, can be written as log of the answer to the base is equal to the exponent, or log of a to the base of b is equal to x. So that means if the exponential form is b to the power of x is equal to a, the corresponding logarithmic form will be written as log a to the base of b is equal to x. Couple of conditions when you talk about the exponential or the log functions. The first condition is, or you can say, the base should be either between 0 and 1 or greater than 1. That means base cannot be equal to 0 or a negative number, or base cannot be equal to 1. These are the different conditions that you need to satisfy before you can create an exponential or a log function. The answer is always greater than 0. Answer means the number that we take over here. Also, the exponents mean the x are always all real numbers instead of all real numbers. Some facts about logs. We call common log as a log with a base 10, which is normally we do not specify that. For example, if you want to write something like a log 25 to the base of 10, there is no base written. It is understood. If there is no base written, you understand the base is 10. And second one is natural log. Natural log is a log with a base e, and e is a constant that takes approximately 2.718. Okay, a couple of examples. Log of 1000 is equal to 3 because 1000 is written as 10 to the power of 3. That exponent comes as the answer here, which is an example of a common log. Another example for common log is log of 100. No base is given. You understand no base means it is 10. Base is 10, so that is equal to 2 because 100 is 10 squared. And also ln. ln is normally the representation for natural log. ln of e is equal to 1 because the base is e. And also the ln of e squared is 2 because ln of e squared, the base is e and answer is 2. So these are examples of common log and evaluating and solving logarithmic equations. Before we start, let's go back and check this again. The exponential and logarithmic form and conversion between those two, b to the power of x is equal to a, and log a to the base of b is equal to x. Let's do a few examples. Write in log form. 3 to the power of 2 is equal to 9. How do you rewrite this one in log form? This is an exponential form. We are going to write this one in log form. And we know b to the power of x is equal to a, and that can be written as log a to the base b is equal to x. So you can just put it as log of 9 to the base of 3, because we know that 3 is the base, so to the base of 3 is equal to 2, and that's it. So log of 9 to the base of 3 is equal to 2. Same thing over here. Log of we will be taking the number right here, that is the number by itself, the number, not the number with the exponent. So we log of that number by itself to the base of 2, which is log 1/8 to the base of 2 is equal to -3. And same thing here. Before we can do this one, we can just probably put 25 to the power of 1/2 because the square root. So if that is the case, you can put log 5 to the base of 25 is equal to 1/2. So this comes from rewriting that into 25 is equal to 25 to the power of 1/2. Now you can see log 5 to the base of 25 is equal to 1/2. Okay. And when you rewrite in log form, the right hand side or the number by itself is always going to be the exponent. You can see that the 2 right there and -3, and you got 1/2 right there, and that 1. So this is actually a natural logarithm. Natural logarithm has a base e, but we never write it down. So we can just use exactly the same format for this, and that's going to be e to the power of 1 is equal to e means ln e. ln means logarithm natural. ln e is equal to 1 because we don't write the base, so the exponent is going to be the right hand side. Now this is backwards. Write in exponential form. Log 16 to the base of 4 is equal to 2. This is pretty easy. I'll start with the 4. Start with the base. Raise to the power of the number on the other side, which is 4 to the power of 2 is equal to 16. So that's what we got here. Same thing, 9 to the power of 3/2 is equal to 27. 8 to the power of -1/3 is equal to 1/2. Pretty easy. And log 1 is equal to 0. So we know if you have a log of a number with no base is given, automatically it is going to be 10. If no base is given on a logarithm, that means it is to the base of 10. So as we did here, 10 to the power of 0 is equal to 1. That's right here. And same thing, if it is a natural logarithm, we do not write the base, but we know the base is e. So e to the power of 1/2 is equal to radical e. Same thing here, radical 5 to the power of 4 is equal to 25.